In this video we're going to look at the encoder bracket, and this is one of the parts that you need to be able to do the tool pass for to reach proficiency. And I've asked you to make two of these parts out of a single piece of aluminum extrusion. Once you first open the part, we're looking here at the XY plane. You can see the part here. To get a better view of it, we can hit the isometric view, and we can hit F9 to give us a view of the coordinate axes. First thing that you should notice is the part is oriented in such a way that if it were made out of some aluminum extrusion, the extruded piece would be lying here along the z-axis. So we need to reorient the piece so that it's made out of a piece of material that can be held along the x-axis. And to do this, I'm going to use the dynamic x-form function, and I'm just going to make a rectangle, hit enter to select, and then it gives us this little gnomon. I'm going to pop it here right on this corner, and then I can rotate it, and then I can click the corner, the origin of the gnomon, and I get a freeform translate until it snaps into the coordinate axes origin. And then I can hit the OK button, and it gives us the piece. To give a shaded view, I can click here. The next thing I want to do is just kind of analyze the piece. And if I go analyze distance, I can see that the height of the piece here is 1.5 inches. Notice delta Z is 1.5. I can click at this corner here and then go to the farthest extent here, and I can see that delta Y is 1.5. And then finally I can check the thickness of the material, which is 1/8 of an inch right there. The other thing that I would like to measure is just how wide the piece is. Since we're making two pieces, notice that the width of the piece is 1.3125 inches. And so I'm just going to actually copy that by going Control C, and we'll talk about why in just a second. The next thing that I'm going to do is make another copy of this piece, since we need to make two of them as part of your assignment. And to do that, I'm just going to use the translate. You can actually use the dynamic X form to make copies as well. I'm just going to use the translate function though. I'm going to select it, hit enter, and it brings up this little window. I'm going to keep copy selected, but I'm going to move it in the X direction by make a copy that is shifted in the X direction by a certain distance. We're probably going to cut this out with a 1/4 inch end mill, and so when I move the next piece, I need a gap of at least 1/4 of an inch, and so I need to translate at a distance equal to that initial width that I copied before, plus at least 1/4. I'm going to go just a little bit more to give us a little breathing room. So 0.26 or 260 thousandths of an inch, and then I can just hit the check mark, and that makes a copy right there. Now that both parts are placed and oriented correctly, we're going to set up the stock. Before we do that, we need to know how big of a stock to create. So I'm just going to analyze how long these two parts are together, and it's just under 3 inches. And so I'm going to make the stock 3 inches long. And to do that, under the mill tab here, if I expand this, I get the stock set up, and I can set the X length here to be 3 inches, and it's made out of 1.5 inch by 1.5 inch square tubing, so the Y and the Z will be 1.5 inches. Ensure that the origin is back here in the back corner, and then I can display as just a wire frame, and hitting OK, you can kind of see the stock outlining the actual part, the actual two parts here. The standard that we use in our team is to have the origin, when we're cutting out of tubing and things like that, the origin is in the back corner here, and so when we zero the part, we're always zeroing off the back corner. The next thing that we'd like to do is then think about how we're going to cut this out. We see that there's these two small holes, and we can analyze these holes really quickly. We can go the distance from maybe the center to one edge. Okay, and so it's 0.1005, and so the diameter would be 0.201, and these holes are really for rivets or number 10 screws, and we use either a .201 or a .196 drill bit in diameter to drill these holes out. And so I'm just going to use a standard drill bit that we have set up in our tools to drill these two holes. And then we're going to want to cut out with an end mill the contour here of these little brackets. And so the first thing that I'll do here is just drill the holes. So we're going to go Tool Path, Drill, and select OK. And we're just going to select the center of each of these points. I'm going to select here, here, and I know it's kind of hard to see. I'll zoom in a little bit. Select there, and then finally there. So the center of those four holes are now selected, and I can hit OK. The next thing that I want to do is select the right tool, and so I'm going to go to Select Library Tool. I'm going to change the folder from the default folder to our Teams folder, Tahoma Robotics Tooling, and it automatically filters. Notice we have 22 tools, but it filters just to a list of 5 which Mastercam thinks that we'll use, which are drill bits. And we're just going to use this number 9 drill bit to do that. And the number 9 drill bit is just the right size for the screws that we use. The standard screw that we use is a number 10 screw or a 3/16 inch rivet if we're riveting. And those are interchangeable hole sizes. We've tried to standardize that, and so that's why we've chosen that. So I'm going to hit OK. And then the next thing that we're going to do is then just go to Cut Parameters. Here we're just going to drill straight through. If it were a really deep, really thick material where we would have to pull out the chips, we could go to like a peck drill and it would peck in and pull those chips out. But we're just going to drill in. And then next to linking parameters, I always like you guys to just choose the absolute tabs on the depth, and so basically it's going to retract to 100 thousandths above the part when it goes to the next hole. The top of the stock is at 0, and then we're going to drill in a certain depth here. And I like to drill in, you need to drill in definitely deeper than the thickness of the material. The thickness of the material is an 1/8 of an inch thick, and so I'm actually just going to type in an 1/8 of an inch, but we'll drill deeper when we get to the tip compensation, and we'll compensate for the point of the bit, and we'll have some breakthrough as well. So I'll just put in the thickness of the material there, and hit. You can hit Apply, and then we can go to tip compensation. So on tip compensation, we want to compensate for the tip of the bit here, and so it's done that based on a 118-degree tip angle, which is what we have, and so it's going to automatically go another 58 thousandths. But we also want to break through a certain amount, and I like to, since it's hollow underneath, I really like to ensure that we break through enough, and so I'm just going to go another 50 thousandths of an inch. And so hitting Apply, hitting the check mark, you can kind of see what's going to happen here. To verify this, we can do a little back plot, and you can, if your tool doesn't show up, you're going to need to select here to show that it shows up, and there's some different options here. We can hit play and just kind of see what's occurring. It's going really slow. To speed it up, we can go here. You can kind of see what's going to happen as the bit goes in and drills these holes. So everything looks good there. So now we're going to actually cut out the material here. And so I'm going to go to Tool Path and Contour and just select the edges here. And so I'm going to select here and keep following this through until the bit leaves here. So the bit would come in here, cut around, and then go out. And then I want to cut out the next one. And so to do that, I say that we're on a new chain, so I just select this and then go around the next piece, and we're done there. And then I can hit OK. Now we're not going to cut this out with a drill bit, we're going to cut this out with an end mill. And so we're going to select the tool, we're going to select tool number 4, which is a great standard tool for cutting aluminum here. It's just a 1/4 inch flat end mill, a 3 flute, and I'm going to hit OK. The next thing that I'm going to do is then go down under the cut parameters. By default, the bit is cutting on the left side of the line direction that I've chosen. So notice the arrow is like this. The bit's going to be compensated to the left side of that arrow to ensure that we're leaving all of this material. It's not going to follow, the center of the bit isn't going to follow the line. The bit's going to be offset by the radius of the bit. And so we call that the bit is compensated to the left here. The depth of cuts, if the material is really thick, we don't want to cut through the full depth in a single pass. This is a 1/4 inch bit. We're cutting through an 1/8 inch stock material. We're going to be fine with doing this in a single pass, so we don't have to worry about chipping away at it at many passes. I'm going to do a little lead in, lead out. This is basically the entry that the bit takes before coming into the stock, and then we're going to lead out. By default, it's set at 100%. The length is 100% the diameter of the bit, which is just a 1/4 of an inch, and you can change that. Notice if I change it to 50%, that's the diameter, 50% the diameter of the bit, which would be 1/8 of an inch. And you can see what's occurring there. We're just going to keep it at default is fine. The breakthrough, we definitely want to go through a little bit deeper. I like at least 10/1000ths of an inch when we're cutting this to ensure that we cut through all of the material. We don't have to worry about finished passes or anything like this, that we can start out a little bit wider and work our way in. We really only need to worry about that when we're really concerned about the finish on the outside, if we want it highly polished, etc. And we're just trying to cut this out, so there's no worries there. No need to worry about tabs here. And then finally we'll just go to the linking parameters. Again, I like to set everything at absolute, and we're going to go a depth equal to the thickness of the material, which is 1/8. Notice it's going to cut more than 1/8 because we have the breakthrough. So we have a 10thou breakthrough plus 1/8 of an inch, and so it's actually going to go 135,000ths deep, or 0.135 inches. And hitting the check mark OK, you can kind of see what's occurring here. The lead in and lead out is pretty large, and we could reduce that. And we don't typically have to have an arc here. We could actually come in straight and then come out and then do that. It's fine if you have this. One issue, if you have a really big arc coming in and out, if you have a long piece on our mill, you might reduce the length of the total piece that you can actually cut, because the bit's going to come out here and it use up the usable space of the travel of the mill. And so since we only have about 18 inches on the small mill and about 30 inches on the large mill, consider that as we're trying to cut out pieces that are almost the size of our total X travel. So to change any of those things, those parameters, we can just click on the parameter tab. I'll go back to lead in and lead out. Maybe I'll get rid of the radius, and I can just copy whatever I did here to the lead out by just selecting that. I've gotten rid of that, and we'll see what difference that makes. So I'm going to hit OK. I'm going to regenerate, and then I'm just going to verify that operation. You can kind of see what's going to happen. Okay, everything looks good there. So now this first operation is actually done, and so we're going to save this file by going File, Save As, and I'm just going to save it as the chassis encoder bracket. And what we typically do is do an underscore and write op1 for the first operation. And so once that part is saved, we can now start reorienting the parts for operation number 2. Before I do that, it's a really good habit to go File and then Save As and just save it as operation 2. What I've seen people do so many times, and I've done this myself, is I've reoriented the part, done all the tool paths for operation 2, and then hit save, and it's just resaving it over op1, and then I have to go back. And so it's a good habit to just save op to before you do anything else, doing a save as. Now what we need to do is get rid of these operations here, and so I'm just going to right click, select them both, and right click and delete, and it says, are you sure you want to? And I'll say yes. And now we're going to rotate the part as if you were rotating it in the mill, and the way the default standard that we've chosen on our team is you take the part, and so imagine this piece of stock here, and you're turning it away from you. And so if you're turning it away from you, then the front part of this piece will now be at the top. And so to do that rotate, I prefer just using the dynamic transform. And so I'm going to select both parts, hit enter. I guess I need to go here and go to dynamic X form, and then it gives me this. Nomen, I'm going to click here and then just rotate the part by 90 degrees. Notice that also it's now up too high, and so I need to translate the part as well. And to translate, I'm just going to use the translate function, and so I'm going to select the part here, hit enter, go transform, translate. I need to translate this in the negative Z direction by negative 1.5 inches. Need to make sure that I'm moving and not copying, and it kind of gives you a preview of what's going to occur, and then I can hit OK. So now that the parts are rotated for operation 2, we can do the tool path for operation 2. The only tool path that needs to be done is we need to cut along this line here, along this edge, and then on the same for the other part. And the reason why that's all we need to do is if you consider the tubing to have an 1/8 inch wall, really all we have to do is cut along those lines to break that free. And so we're going to go Tool Paths Contour and choose this line here, and then the next one on the same one on the second part right there. Now the reason why I'm going this direction is because the compensation is the default compensation of the bit is on the left hand side of the line, and so think of the arrows. Let me turn the part around here. Think of the arrows going this way, and so the bit is going to be going here following on the left, and so we'll go OK. Now we have a lead in, lead out. I don't want the radius there, and we can shorten it a little bit as well. We'll talk about maybe why that would be useful. And the next thing is the breakthrough. I'm going to have no breakthrough, and I'll mention why in a moment. And then finally on the depth. Now I don't really want to go all the way through, and so I'm only going to go negative 0.1 instead of negative 0.125. That's going to leave about 25 thousandths of material there. The reason why is we're going to flip this part 2 more times, and we're going to compress it in the vise, and if we just cut through, we really don't have a rigid piece of stock to hold, and it will just crush under the pressure of the vise, and the parts will not be machined correctly. And so we want to cut it most of the way, but not all the way. So what we're going to have to do when the part is all machined is we're going to have to kind of break it free and do a little filing. And it's important that you don't just cut full depth all the way out on these little brackets that we're cutting out, or as you turn the piece of tube to the other operations, the tube will compress, or the parts will start to loosen up and fall out. And so fitting this part to the screen, looking at the back plot here, we can hit play, and you can see the bit cutting, and it has about a 1/2 inch lead in. Now one thing that I've just noticed is that I forgot to change the tool and choose the correct tool, so I'm going to go up here and go to tool 4, again the 1/4 inch end mill. I have to regenerate that dirty operation. You can see the little X here, meaning that I've changed something but I haven't regenerated it. So I regenerate the operation. We can see that there's a change, and we can see what the bit will do. And that looks great. And so operation 2 is done. Now that operation 2 is done, we're going to just get ready for operation 3. But before I do that, I'm just going to go File, Save As, and start operation 3. And now the next thing I'm going to do is, instead of deleting the whole operation, I'm just going to delete the chains, and we'll talk about why in just a minute. So now we're going to rotate the part using dynamic X form. You can use the rotate function, but I think dynamic X form is a little quicker. And so you can select a corner, turn the part 90 degrees, and then we want to move the part up here, in this case in the positive Z direction. And I think the easiest way to do that, since we don't have a nice corner to grab over here, there's nothing there, is just to use the translate. So I'm going to go X form translate, move in the positive Z 1.5 inches, and make sure that I move. And now that the part is there, we can start adding some chains. Now, instead of just starting a new operation and changing the parameters, I'm just going to go to the geometry here and add a chain, and we're going to cut out the perimeter here, and I'm going to start here. Again, the reason why I'm going in this direction is because the compensation direction is on the left side of the vector that describes the direction of motion of the bit. And so we'll just go around here. It takes a little care as we go around and select each part. As I get to the end of this chain, I need to hit this button or the letter C, the shortcut, to tell the computer we're starting a new chain. If you don't do that, there will be a little error window that pops up. So now that we've made it to the end there of the cutouts, we can go OK and hit regenerate, and we can verify that through the back plot. We can see what's happening. Again, notice that I didn't have to go through all of the details and the parameters because it's just saved from the previous operation. Again, tool 4, the lead in is the same before, and then importantly, the linking parameters here, I'm not cutting all the way through on these brackets. I'm leaving 25 thousandths. And that is about right, 25 thousandths. You could go a little bit more. The thicker, though, that you make it, the harder it is going to be to cut it out at the end by hand, and more filing work. So there's a balance that you'll need to find between how much material you leave to keep it rigid in the vise and how much time you want to spend doing the filing. So what also needs to be done is we need to add some contours to cut out these holes. And I'm not going to just add to the geometry here, because I want to go deeper to make sure that I cut all the way through the material there. So I'm just going to go Toolpath Contour and then select each edge here, making sure that we're going counterclockwise. And after I've selected all of them, we can then go to the tool, ensure that we're tool 4. There's not a lot of room for a lead in and lead out because of the holes being so small, and so we can just take that off and then go down to the breakthrough. We're going to go again 15 thousandths is a good number there for the tubing, and then on the linking parameters we're going to type in the thickness of the stock, again with a negative 0.125. Hit the check mark, and we can kind of see what is going to happen there with the back plot, and everything looks good there. Now if you'd prefer to change the order up and drill the holes first or contour the holes before doing the contour on the outside, you can drag one operation to the other, and so now the contour with the 6 chains or the 6 holes is first, and then the contour for going around the edges or the perimeter is second. We can select both operations and kind of show what that would look like. And so we're drilling the holes first, and then we're going around and cutting out the part. Now looking at the part, looking at the 4th side, there's really nothing to be machined there except this little cutout here, and so that's all we need to do is just do the cutout to separate the two parts. And so I'm actually going to delete the operation that has the hole cut out, and I'm just going to delete the geometry for the perimeter cutout for operation 3. And then I'm going to go File, Save As, operation 4, and then we can rotate the part and do the work there. So I'm going to go X-Form, Dynamic X-Form, and select the part, rotate the part 90 degrees, do a quick translate in the negative Y direction, negative 1.5 again. I'm sorry, it's positive 1.5. And now that the part is in place, we can just go here to Geometry and go Add Chain. We want to be going in this direction and then this direction here. Again, think about the bit coming. It's going to be on the left-hand side of the line as it follows this path and then goes back the other way. And to check our work, we can just go do the back plot there, and we can see that it's cutting out that direction and that direction. One thing that we want to see is that we're not going the full depth. We're only going 100 thousandths deep, and you can see that it's going to leave a little bit of material there. We can just check that again with the parameters under linking parameters that it was just saved from the previous operation. Now that we have that, we can save it, and we're done with all 4 operations.